Hi, and welcome to everyone joining. So this is the Fireside Chat with circuit designers today as part of the Circuits Insights program. So what this part of the Circuits Insights is, it's basically it's a conversation with designers who graduated within the past 5 or 6 years and are working in industry today. We put together some questions that are aimed at for undergrads and early grad students who are either pursuing a career in circuit design or are considering next steps in their education or career. So I'm really excited to be talking to these 4 panelists today, and we'll go ahead and get started. So just as a brief introduction, so my name is Frank O'Mahony. I work at Intel, and I'm also the ISSCC Forums Chair this year. And then before we get to our panelists, I also want to give a quick thank you to Jeremy Cosson-Martin, who's volunteered to be our recording engineer today. He's a student at the University of Toronto. So thanks, Jeremy. Okay, so let's start off with the panelists. First, for an intro, we'll start with Alicia.
Thanks, Frank. Hi, my name is Alicia Klinsfelter. I am originally from a small town in Ohio, which is a state in the United States, and I have done my bachelor's in electrical and computer engineering and my PhD in electrical engineering, I guess in the last decade or so, with my PhD being from University of Virginia. Now I work at NVIDIA as an ASIC designer, and I've been there for 5 years. I actually started off in research, but have transitioned over to product, where I now do GPU interconnect design, and have been doing that for a little, I guess, about a year now. It's something I like to do outside of work. I am a beekeeper, which is very enjoyable, and I also am kind of an amateur homesteader, so I have quite a few farm animals and do that for fun.
Really cool. All right. Thanks, Alicia. So next we'll go to Elsa.
Hello. So yes, my name is Elsa and I'm from France. So after my master's in semiconductor physics, I did a PhD at the University of Nice Polytech Lab in collaboration with ST Microelectronics. The topic of my research was the development of a low-cost, high-speed link based on integrated sub-terahertz antenna. And right after my PhD, I was hired as a pixel designer in research and development at ST, again, in Grenoble, France. So it's been 3 years now, but 6 in total. So there are 2 key activities to what I do. I design and optimize pixel integrated circuits, and I also use TCAD, which is another tool to simulate electrical behaviors of semiconductor device. So in the end, it's the innovating aspect of our mission is very major and very thrilling. Outside of work, I like dancing, listening to music, hiking in the mountains that are nearby, luckily, and I love food.
Great. Thank you, Elsa. All right, next is Phillip Nadeau.
Thank you, Frank. I'm Phillip Nadeau. I'm originally from a suburb of Toronto, Canada, so a very special welcome to any Canadian students watching. I have a bachelor's from the University of Waterloo and a master's PhD and postdoc at MIT. And now I'm at Analog Devices. I've been there for just over 4 years as a senior research scientist. I work on hardware and algorithms for bioelectronics, which is continuing a big theme from my PhD. And one of the big initiatives that we're working on is a chip for DNA synthesis in collaboration with the startup. And let's see, outside of work, maybe a fun fact, maybe one of the more unusual ones, I'm known for playing this Canadian sport of curling, which is where you slide those 40-pound pieces of granite down the ice and try to make them stop in a painted target at the other end of the ice, which they call a house. So a standard curling joke is I get to throw rocks at houses in my spare time. So that's a quick summary of me.
Great, thanks, Phillip. Yeah, curling seems to get highlighted during the Olympic years too. So this is a big year. I'm
it's
guessing.
A peak popularity for the sport.
Yeah. All right, thanks, Phillip. And last, Preet Garcha.
Thanks, Frank. I'm Preet Garcha. I was born and raised in Punjab, which is the northwestern part of India, bordering Pakistan. My family immigrated to Canada to Calgary, Alberta in Canada, so that's where I did my bachelor's in electrical engineering from. That was the University of Calgary, and I wear this iron ring as proof that I got my engineering degree in Canada. And then I did my master's and PhD in electrical engineering and computer science from MIT in Cambridge, Massachusetts. My research projects at the time were sponsored by Texas Instruments. So after graduating in May of 2020, I joined Kirby Labs, which is the research unit of TI full-time. And I'm in the sensing group, and we work on circuits and systems design for magnetic sensing and current sensing applications. I relocated from Boston to Dallas during the pandemic. And outside of work, I love to travel, but because of the pandemic, I wasn't able to leave North America all of this time, so I found Dallas to be a pretty convenient location for small domestic flights, so that's worked out.
All right, great. Thank you so much, Preet. All right, well, let's get started with some questions. So the first question, I'll go right back to you, Preet. So that is, how did you end up as a circuit designer, and how or when did you decide on a focus area for study, either in undergrad or grad school?
So that was somewhere during my third year of undergrad. I knew I wanted to do something in the semiconductor area long before that. I loved device physics, learning about p-n junctions, and I loved all binary arithmetic courses, VHDL, everything sort of related to semiconductors. But towards the end of the third year is when I really decided I wanted to be a circuit designer because of how much I loved learning about CMOS in particular. And between digital and analog, analog was cemented for me during my internship. I did a 16-month internship as a high-speed analog IC design intern, and it was the best time of my life. And that's when I decided that that's what I want to do.
Great, thank you.
Yeah, I could jump in too
if
you're sending the questions around. So for me, it was a little bit earlier. I would say my earliest memory was tinkering with electronics. I built a telegraph about halfway through grade school, and also a crystal radio. And especially the crystal radio, I was just fascinated by this idea that you could pick up all this invisible energy from the air and, drive the earpiece with the radio signal. And, more so than mechanical engineering where you could, see the cogs, one turning the next, or chemical, you could sort of see the reactions happening. I was really fascinated by this idea of, manipulating the invisible. And so, I think that started a passion for trying to understand this area a little bit better. And ultimately, that's the area I went into.
Yeah, great. So that was actually even before like university.
Yeah, that was way back, and then it was between electrical, maybe computer, because they have sort of similar properties in terms of manipulating the invisible. But I kind of liked being at the hardware level and the physics, and not being so high on the abstraction layer. I really wanted to figure out and manipulate the kind of the lowest level. And so probably later, first year undergrad is where I really kind of pivoted towards electrical and away from computer. Yeah.
Great.
I actually
Anybody else want to weigh in? Yeah, go ahead.
A very different story from Phillip, so I'll share it just for the purpose of, having both endpoints. I think, I definitely I wanted to be an applied mathematician when I entered college, and it was very abstract. And I actually really liked DSP and digital signal processing in more signal processing parts of electrical engineering when I started. But it wasn't until I started to kind of learn more and want to apply that much more practically, probably somewhere in the middle of undergrad, the late parts of undergrad when I took a VLSI course, that I actually decided that that's what I really wanted to do, is kind of the intersection of those two topics. So it came to me much later than earlier.
So we have all ends of the spectrum.
Yes.
Exactly. Yeah. All right. Well, let's we can move on to the next question here. And actually, Alicia, we'll move right back to you. So I think one of the tasks that someone has to do if they're kind of an undergrad and looking at majoring in electrical in circuit design or thinking about grad school is finding an advisor. So I was wondering, like, how did you find an advisor for your studies?
Sure. Yeah. So I think when I was first finishing undergrad and I was thinking about DSP or IC design, and I looked actually, it was a much smaller world to me at the time. So I was looking at a lot of schools in the Midwestern United States. And I saw there was a young professor at the University of Virginia who was focusing on this. And I applied and, I got in and I went to the orientation day for the university, which I highly recommend if you get the opportunity to do, if you can meet professors and meet students in your lab. And when I toured, his name's Ben Calhoun. He's fantastic, and he was so high energy and organized, and he showed me all of his students, and I got a chance to interact with them and meet them. And IC design's a really highly collaborative field, especially as the ICs get a little bit more complex, at least in my opinion. And I think I realized, like, these are going to be people I'm going to interact with for a long time, 5 years. And I think it's going to be really important that I have a good relationship with the people in the lab, and then also that I feel like I have a good relationship with my advisor. And after meeting him, I met a bunch of other advisors at other schools, and no one really compared. And he kind of sealed the deal for me, and it paid off. I actually had an excellent time at graduate school and had really good lab mates that I still know to this day. So yeah, I recommend meeting people in person and going to those orientation days if you can.
Great, thank you. Yeah, the orientation, that's a great advice. Like visiting, it's a little bit difficult during the pandemic, but going and visiting and getting a feel for what your life is like there, that's a great idea. Anybody else want to join in on this one?
Yeah, I could quickly join in. So I used his textbook in undergrad. That's how I first came across him. And when I was applying, I started researching the lab and reading papers written by the students. And all the things Alicia said, like, I went to the orientation. He was super helpful getting me set up with his current students. And something that some advice I got was, also talk to the alumni if you can, or at least research them a little bit and see where they're going. Are they going to academia, or are they going to industry? Are they still doing circuits? Did they give up on circuits and pivot to finance, or maybe, law or something totally different? So that was really important advice, and I got in touch with some of them, thankfully through the help of my, ended up being my advisor. And, all of that checked out, and I knew I wanted to stay in circuits, and many of the alumni did as well. It was a phenomenal lab. All the current students were great, and I got to meet the advisor at the orientation. Highly recommend you do that. And confirmed it was the lab I really wanted to join, and lucky enough, he said yes.
Great. All right, well, let's move on to the next question here. So this is going to be we'll start out with Elsa on this one. Yes. So one of the things I think that is can be difficult as a student is to sort of imagine, like, hey, what is my daily life going to be like if I'm working in this field? So I was wondering if you can kind of describe a little bit about what you do now. What does like a day look like? And then what do you find like challenging or inspiring about the work that you're currently doing?
Yes, of course. So me and my team, we focus on the development of time-of-flight optical sensors based on Sickle photon avalanche diodes, and it's all in standard silicon technology. So those diodes, they have gained a lot of visibility due to their picosecond timing response to incoming photons. And as a result, some of the targeted applications are LiDAR for autonomous cars or 3D imaging. And actually, most smartphones are embedded with the SPAD techno developed by ST here. So you can grasp the industrial dimension of what we do. So to be more pragmatic, so one of my missions with the team is to design, simulate, and optimize the pixel integrated circuit connected to the SPAD diode. To do so, I use SPICE electrical models and tools such as Cadence. Maybe some of the undergrad students have encountered such tools. And now I also continue the work of developing innovating simulation test benches based on TCAD mixed mode, TCAD, which is much more oriented towards semiconductors. So instead of studying the circuit behavior, I study the electrical behavior of the true SPAD semiconductor device under light when it is plugged onto the quenching circuit. So this gives us a good insight on things we can improve in the SPAD semiconductor architecture or in the circuit performance. So as you can imagine, there are a lot of performance metrics that need to be optimized in order to stay competitive or offer new applications. So we need and have to develop a very good modeling capability. So we always need to be on point on that. But I really like that what we do is quite new, and therefore there's always room for innovation. So that's very inspiring. Never boring.
Great. I love how you kind of connected it directly to the application that what you're working on is doing. Anybody else want to chime in on this one? Basically like what's the work that you're doing now? What do you find challenging or inspiring about it?
Well, I could chime in quickly. So I'm in the Analog Garage, which is the corporate incubation lab of analog devices. And I mentioned we're working on this DNA synthesis chip in collaboration with a startup. So it's CMOS, passive layers, and then packaging on top of that. And I'm leading one of the sub pieces of that, which is the passive layers getting built on top of the CMOS. There are multi-physics simulations and circuit simulations. And I guess what I find the most fascinating is, this is a highly multidisciplinary project. So it starts with biology, and then there's chemistry, the process of building the DNA base by base, and then the physics of how you do it, which is, it turns out, heating some individual sites on the chip. And then the fact that, there are hundreds of sites on the chip, so you need all the analog and digital to run all that. And it's just a really interesting and complex set of constraints. And hopefully if we're successful, it'll be important for things like vaccine development or cancer treatments or agriculture or maybe a few other areas. So it's a really interesting project.
Yeah, and I like that one because it sounds like it's circuits, but it's bio focused application, right?
Yeah, it's a whole stack there. Yeah.
Yeah. Great. Well, why don't we move on to the next one here? So this one, actually, Phillip, we'll go back to you on this one. And, as students are kind of planning out what classes to take, one question that comes up, I think, is like, what's the skill set that employers are looking for today? So like, what kind of background in terms of education, internships, do you feel like are good for a circuit designer to have?
Yeah. So, maybe following on from the last answer, a lot of the developments, and I'm sure others can relate, are getting more complex. Maybe in history it was enough as a circuit designer to build like a circuit block, like a PA or an LNA, and really push some kind of a specification. Maybe it's noise or power or linearity. And, there's still many problems like that, but things are getting really complicated. So I would say if you're considering going into circuit design today, you should focus on being an expert in some area of circuits, maybe the one you're most passionate about, to sort of teach you how to think about circuits. But then you kind of have to go broad and learn how to, put a bunch of blocks together and deal in abstractions, simplify each of the blocks and understand how they fit together in a big system. So probably my recommendation would be, go deep in at least one circuit area, but then explore and try to get some base level of understanding of as many areas as possible.
Oh yeah, good advice. Anybody else have any thoughts on this one?
Yeah, I would love to. Yeah. Oh, sorry. Oh, second.
Go ahead.
Well. Okay, just making sure I didn't want to cut you off. But yeah, actually, for an SSCS article I did a couple years ago, I actually scraped a bunch of data on circuits jobs to see what the number one or two skill sets people were looking for. And what was really interesting was that the top skill sets were actually software related. They weren't really circuits. You start to see a lot of like Python, Perl, Tcl, you start to see a lot of these software, C++ for verification or something, and you start to see things that are not necessarily circuit related. So to kind of back what Phillip said, it's good to dive deep in circuits, but also not get too devoted to one or two tools or one or two skill sets, because those start to evolve very quickly over time. So I try to be really open to almost kind of switching on a dime if I need to change a particular skill set or way of things or way of doing things in my job. And just kind of being open to needing to change frequently actually is a good skill.
Cadence Virtuoso is making its way down the list of skills, and Python is moving up.
Moving up, up-leveling, yeah. That's great. Preet, I think, were you going to say something here also?
Elsa, I think.
Okay.
Or Elsa.
Yeah.
Sorry, Elsa. Sorry, go ahead. Yeah.
No problem. No, I agree with Alicia. Actually, I think that around circuit designing, there are a lot of different disciplines complementary to that. For example, characterization, or you have analog or digital. You have the mechanical issue of packaging, and they're all interdependent, and actually they can all be useful for that. Me, for example, I was asked to do quite a hybrid job, not only circuit design but also semiconductors, so touching a bit of different things, which is really nice. So having just not focusing on one stuff, but knowing that you can broaden your spectrum, and because people are also interested in this kind of profiles, it's very, very interesting.
Great, thank you, Elsa. All right, so moving on, I think that having internships or doing academic research is also a great way to kind of take what you're learning and figure out what does it look like as a career of applying that. So I wanted to ask about internships and academic research. Did you have any academic research or internships experiences as an undergrad, as an early grad student? And also, how did those experiences go? How did you find those? So Preet, why don't we start out with you on this one?
So yes, I absolutely did both of them, but the biggest impact in my life was from my first internship experience. That was a 16-month internship with the last semiconductor company on the Toronto Stock Exchange, Denim Corporation. And it's a longer story, but with a few takeaways. How I got that internship, how I picked that internship, and what that internship did for me. How I had found out about this internship was through a very chance meeting with our electrical engineering head of department, Dr. Rosehart, and I talked to him about all the things that I liked and what I wanted to do, and he recommended this one internship position. The thing is, in Calgary, there was only one IC design company, and they only hired one intern per year. And that year, they were late in applying for the program, so there were no IC design positions at all. So I interviewed with whatever other companies were there, and there weren't a lot many because I was in Calgary, which is primarily oil and gas. And I was about to accept one of them. I had to accept an offer by Monday, and I just happened to email Dr. Rosehart on a Saturday from my solar car team workshop and tell him that FYI, I'm taking up this internship offer, which is about PCB testing and verification. And he was such an angel. He's like, no, please, I insist, let me talk to Denim Corporation and hold off on this until Monday. And he had booked me an interview first thing Monday morning, and I had an offer a few hours later. And if I had not talked to Dr. Rosehart, and I'm an introvert, so I don't talk to people, but if I had not talked to that professor, I would not have got this internship. I would not have, maybe not have done grad school, not have come to MIT, not have enjoyed life so much. So talk to people, that really helps. The other thing is money-wise, this was the lowest pay out of all the internship offers that I had, and definitely lower than oil and gas and any other internship offers that were out there. But in terms of experience, it was invaluable. It was the best experience ever. I got to own sub-blocks on 2 chips, which went into production. One was a 10 gigahertz clock and data recovery chip. Another was a 6 gigahertz video reclocker circuit. I didn't know what they did at the time, but I independently owned a few sub-blocks from design phase, schematic design, verification, layout, post-extracted simulations, design reviews, layout reviews, all the way through tape out. And it was phenomenal. And mind you, I had not taken a single analog design course before this internship. So I went in knowing nothing. I had never used the Cadence, any tool out of the Cadence suite. And I was writing motion scripts, scale code. Going back to what you were mentioning, Alicia, a lot of coding, scale codes as well, just to make my own life easier. And it was phenomenal. And that's when I decided that I need to do grad school to learn more about circuit design so that I can be a really good circuit designer like all the principal design engineers that were at this company. And that's how I applied for a PhD. Later, I realized that that's not how it works. So even after I graduated, I'm still not at their level. But in summary, I highly recommend internships. Yeah,
it really sounds like this internship really changed the direction of your career, right? And I think I'll just point out another through line, I think, between this and where we were talking about advisors is just kind of, it sounds like it's like taking that chance to make a contact, to make a connection, and how much that can kind of change your, it seems like a small thing. It can be a little bit of a frightening thing, at least I can say from my experience, but it can open doors and make a difference. Good. Anyone else want to talk about the internship or academic research question?
Maybe me a little something to add. Yes, between what I have studied in master's and my end of master's internship and then PhD, it is two completely different things. So during my studies, I specialized in semiconductor, and then I ended up doing a terahertz antenna, which is completely different, and it went on perfectly well. So my point is to not be afraid of going into something that you don't feel comfortable in because you haven't studied the specifics at school. School gives you a very good skill set on, working methodology, the basics of physics, but then you learn so much more and such different things throughout your career or your internships. So not having specialized in what you're going to do in an internship or even as a job is okay, because you can learn
while you're there. Yeah, that's great.
Yeah.
Good. Well, I want to move on. I want to get to this last. I think this will probably be our last question because we are, believe it or not, we're almost out of time here. So this will be a question. We'll start with Alicia on this one. So one thing I always think when you look at people in the field is from the outside, it may look like their career has been very linear or very planned out. And I know that, in reality, that's usually not the case, right? That the way things turn out is not necessarily the way people sort of think that their career is going to go. So I was so in this case, I wanted to talk about, how does your career look now compared to what you had thought as an undergrad? And anything that you think like your undergrad self would be really surprised by, if they could know.
Sure. Yeah. I mean, I'll not even just undergrad self, even my PhD self,
sure.
I think now would actually be surprised, and I think there's quite a lot of difference. I think I mentioned at the beginning that I started off in research and industrial research, and I've progressed over to doing product design. My PhD was in low power electronics. I'm now doing high speed electronics for GPUs. I think basically it's been a lot of shifts, and I've had a lot of moments where I basically just checked in with myself to kind of say, do I actually like what I'm doing? And I don't just mean the technical part. Do I like the whole context of what I'm doing? Do I like the people I'm working with? Do I like my manager? Am I doing something I enjoy day to day? Not just something I think looks good to the outside, but something I genuinely enjoy. And being able to check in with myself to make sure the answer to those questions is yes, in making changes if they're not. So I think that's helped me kind of make a couple of pivots that have made me now, present day, very happy. So I think it looks very different in the sense I always thought I would be a researcher, and I'm not. For example, I thought I'd be a applied mathematician doing DSP, and I'm doing IC design for interconnects. So I think my only piece of advice is just always remain open. I think whether you're an undergrad or a PhD, don't think that it's always just going to be that one thing that you chose, and just remain open to changes throughout your career.
Great, thanks, Alicia. Sorry, so we actually need to end here. We got to stay on time. So I want to say, just once again, thank you so much. So Alicia Klinsfelter from NVIDIA, Elsa Lacombe from ST Micro, Phillip Nadeau from Analog Devices, and Preet Garcha from Texas Instruments. Thank you so much for joining us for this panel, and we'll end here.
It's a pleasure, Frank. Thank you so much.
Thank you.